Hi, today I will show you how I catch Uranus and then take a picture of it or making a movie with my zwo224. I will use the 9 mm eyepiece from Explore Scientific 100 degrees because for me it's a very nice eyepiece and it will be better it will help me to find because of the 100 degrees. Some people don't like the wide fields of view of the eyepieces like this 100. Oh, that's too much for me, I don't like. Okay, but to find objects, and that's my strength here, finding objects. I'm very good finding objects and star hopping, and this kind of eyepieces helps a lot because you can see more patterns, star patterns, and your brain will identify better the object you are trying to catch. Now, I will use my 12-inch Dobsonian. It's properly collimated. It's cooling down for a long time now. It's prepared to go. Everything is aligned. It's very important to align the finder and the tail rod. It's very important to catch this outer planet. And then I will have to change the eyepiece after I catch the planet. I will change the eyepiece for the 2x Barlow that I have from the Explore Scientific also, and also put the camera. Now, the camera, this camera has a teeny, a small field of view, like seeing from a 6 mm eyepiece. I will put a Barlow, a 2x Barlow, so it will be like seeing from a 3 mm eyepiece. That's crazy. And to catch a tiny planet like Uranus. So I will do it. I will prepare the laptop. I will wait for my dark vision to be adapted. This is very important to have a good dark vision and to have a good seeing. To see this kind of objects, little objects, very important. So see you. Okay, I already catch it. It's not already fully dark, but I catch it. And I have with my geoptic platform, I have it in my field of view, so I have no problem for it to run away because it will be fixed there. That's the advantage of this platform. Without it, I doubt that I could make the video because it's so small, and with the camera now it will be another hard part. Now, I use also a trick. What I see now in the finder view, now that I have the planet in my eyepiece, what I see in the field of view of my finder, not the Telrad, the original finder scope, it's very important because sometimes when I change the eyepiece for the Barlow and the camera, the balance of the telescope will be crazy, and I will lose the planet. And with the camera there, the only way I have to back again to the same place, it's with the pattern that I have in my head of what I saw in the field of view of my finder when I caught the planet. That's a trick that I have to maintain the things, to keep the things and put it back where they are. otherwise I will have to put again the eyepiece, and then it's like a circle, because you put again, but then you have to change, you lose again. If you don't lose, hopefully I don't, good, you will moving forward, but it's a risk. So to avoid that, for security, I memorize the pattern, the star pattern, and I know more or less where it is. Now I will put my laptop. I'm with these glasses because my dark vision is faster adapted. The adaptation is faster with these glasses. It's red glasses. So and I need this dark vision while I'm doing this job of looking for the planet. Now at the moment that I open the laptop, even if it's red, the screen, it will blown my dark vision, and I want to do this fast, because after this video I want to make my observations, and I need again the dark vision. So just a moment. Now the planet is there, you see. Now what I'm going to do, I'm not an expert in this program, in SharpCap Pro. I just move the exposure and gain, and then I save the video. But what I am trying to do now is to reduce even more the field of view. So this capture area, the pixels, I will try to reduce and keep it on site. Hold on. I'm not an expert in recording these things, but I will try to. So one thing that I do for the people that like the equatorial platforms, I try to, in visual I don't need this, but to photograph I try to find the balance of the speed. It's very important. In visual I can put 5, 6 or 7, and the speed is always, the object is always in the field of view. I try to focus a little bit. This is very hard to focus, because one little touch, even the wind. I will make just a video. Start capture, unlimited, and I control just the speed, because if I put more speed, you see, if I reduce the speed now, it's going to the left. I will try to put this. If I reduce the speed now, yes, I think I'm getting the point, the balance point. Well, this is a job to do, the patience of finding the balance. I just want, I'm not from astrophotography. I'm a visual guy. I just doing this to show you how it works, and sometimes I do this, but that's not it's not usual. Now I will try to, I will stop. This one only a test, and now I will try to change. Now I have to put again the speed for the planet not run away. Now I don't know how to put again, to save again. I'm not an expert in SharpCap, that's true. You have to learn SharpCap from other people. I'm just cancel. Okay. What I want is to reduce the field of view. Here I will put I don't know, 70, a little less can be. This laptop is not also 640. Okay. Start capture. Start. Now I have to control well the speed. I'm not. Oh, faster. No, less speed. Yes, less speed. You know, I usually don't worry about this. I put more or less the speed. The thing is, the telescope is aligned, and that's for me the most important. It's well collimated. This kind of movie or video I do sometimes. I did it before. I saved the picture. Was a very nice picture. You could see on Facebook. A lot of people was delighted with this picture I took. I'm doing exactly the same. As you can see, well, I'm controlling the speed. Now I will put a little more speed because it's only a little bit will change the things, because remember, we are with a Barlow with this camera. The 3mm I had now is more because a great magnification, because I cut the field of view, the pixels. As you can see, I have 640 by 480. Now it's not getting focus here. I don't know if the gain is okay. I will reduce a little. No, I don't think so. But as you can see, the object stays in the field of view, which is very small, and it keeps recording. So I suppose for DSOs, I don't even try yet, but I will not now. I will wait for the weather to be hotter, but I will do the same. I will make real-time videos when I took a picture or a video of the DSO. Ui, I touched the scope. It was like horrible. I touched this. I will try to focus again. I can focus well, but the problem is I will stop this capture and I will start another with now. I think it's better focus. Speed again, increasing the speed. I will increase the speed, and the teeny planet, see, stopped. Probably here is the balance point of the platform. I don't know. I just, oh, it's running away. Oh. See this. If I put in the pixel size, the bigger one, it's easier. And if I don't put the Barlow, even easier. But I like challenge, and to take a good picture, I have to do like this. Oh, it's getting. I touch the telescope. I will try. Look, yeah, I only touch with a finger, and look at the planet, how it jumps. I gently touch, and this is incredible. Now, I think you got the point. Now I will save. I think it's saving. If you want to know about ShareCap, there's a lot of nice guys that put some videos about it. I'm not an expert, as I said. Maybe in the future, but not now. I have to be honest. Look how beautiful it is now. Look at this beauty. See it? Look at it. I don't know if I'm not also an expert to record at night with a tablet. See how beautiful. If you can get it to the middle, right to the middle, you can even you can cut even more this field, and have more better frames. Oh, is it crazy? Okay, that's enough. That's enough. That's enough. Stop capture. Okay. Another thing that I want to tell you before I forgot. See how he's still there. The camera. I will try to show you. The best way for me to work with this camera is in this position. Let me see. Okay. Now I will back. See the scope? You see how the camera is? Look at the cable. It's in the diagonal. Look. This, I'll try to tell you. This side, upside here, this screw of the camera, it's pointed exactly on the vertical, and both the bottom too. So what I do is to put this cable in diagonal. You see? Diagonal. A 45-degree angle from the focuser. You see? 45. Why? Because if I move left, if I move the scope left, in the camera, in the screen, will go left. If I move it up, it will go up and down. And if you put the camera, for example, to the cable down, because you think it's beautiful like that, and you don't mind, and you don't know this, what will happen? You almost catch the object, you see it on the screen, and oh, a little to the left, you try to turn the left, and this will go up, and things like that. So you have the hard job of finding everything upside down. Your brain adapts to this, to catch the things, and you know already that is like a mirror. Okay, but then if you have the camera, that is also a hard job to do, to focus at the camera, the object that you already have, and you almost get it, or you want to adjust to the middle, to do like me, to put the screen smaller, the field of view smaller, to have more frames, and you struggle, you lose your patience. It's impossible. It's human. You will struggle. You will going up and it goes left, or the other side, or in diagonal, which is worse. You can't figure how to do it. So please remember this tip. With any camera, I think it's the same. Try to find the position. For me, it's 45 degrees to the left. It's like northwest, the cable, the USB cable, and you will remember this, and you will be grateful to know that it will make your job much more easier. Now about the platform, you already know this is very important, the speed. When usually I have this like 5, 6, 7, 6. No, usually I have it at 6. But if I put 5 or 7, it will be the same for visual. The plane is still there, no problem. For the camera, while I was showing you the video, saving the video, I was touching this, if the planet was going too speedy, was going to the right, I reduce the speed. If it's going to the left, I put a little more speed. If you have patience, you can find the right spot. You can put it on the middle of the field of view, and you will have better images. Of course, I also will have could have better image if I was taking this picture of at the time of the opposition. I think it was October or so. That is being perfectionist. Okay, now I have this opportunity. I'll catch it. I take a nice picture. I will show to you at the end, and I'll try to show you. It's very easy to catch it. You just, if I can see it here, I show you. You see Mars, Uranus, little left and down, and here the constellation, this star. You have Cetus, Aries, and to the right Pisces. So you note that you have a straight line. If you put a straight line in the last star at the right of Aries, I will show you. So here you almost have Uranus at the middle. So you try to position your tail rod in the middle, here, at the middle. You don't know that Uranus is here, but you try to put your tail rod here. Then you look at Mars, and you can see that Mars have the measure of the tail rod is Uranus at the tangent. So another trick, if you want to go from Mars, for Mars it's okay. You don't have you can trace a line, a straight line, because you don't have point of reference. Here it's easy, because you can put a line and then you know it's a little to the left. But you do on Mars, I do the same trick. The trick is I put more or less the position. I know that it's some inclination here. This is in the scope. I make a tangent to Mars, and I know in the other tangent is Uranus, okay? So what I do, but I do like that, and it works fine for me. I fix my eye in the scope, in my eyepiece, I beg your pardon, in the tail rod. I fix my eye here, nothing more, here, and then I keep my eye fixed here in the tangent where is Uranus. I keep my eye fixed and I move slowly the scope like this, but always with my eyes on that point. It doesn't matter that you can't see any star. It's a question of practice. I always have near the planet. Then for me it's easy because I can distinguish the planet from a star. If I have doubts, for example, with Neptune, because this is more greenish, blue greenish, Uranus and Neptune is more bluish only, and it's easy to make confusion with the stars and around it, and you get lost. But if it happens, you do it. And here too, in Uranus, you go star by star, and you do a checkup. Let me take this is over already. The platform has some time. I think it's 1 hour or more, and I have to reset it. It's very easy. I turn it off, but I will see. You will see how this works. I just push this button. This is ended. Now I push this button. That's it. The platform is reset. You see how easy it is to work with this platform. So to finish this, you look star by star, fixing a point. You, for example, you know an area, you know that Uranus is there. You think maybe that star could be Uranus, but you're not sure. That is the power of the Dobsonian, of the aperture. With a 12-inch I can do it easily because I have a big aperture. With an 8-inch it will be much harder, or a 10. You fix the area, then you think that a star is Uranus. You fix that star, and don't. Your brain has to keep that star always in your view. You can move left and out of field of view of the star, but you know, if you don't go too much, you go to the right again, you see the star, you keep going up and down, left and right, up and down, left and right. And while doing this, not doing only this is stupid, this is to star by star focus that star, look only at that star and think if it's Uranus or no, because the planet is different. The planet doesn't shine like a star. The planet is so perfect. It's what I see in the eyepiece. This is for the people that didn't see Uranus or outer planets. When I see, the others know what I'm talking about. When I see Uranus in the eyepiece, it's the perfect circle that I ever saw, because it's so perfect. Doesn't have nothing. It's the shape is perfect. So you will notice, and if you can't do it now, you try later in another position, in another day, a night, when it's closer to a star of a constellation, a star that you can see, and you will get that planet. If you seen this video and you didn't see Uranus or Mars or Neptune, you will see it, but you have to be patient. And after you see it, you will want to do what I did today, a nice picture. Now at the end of the video, I will process the picture. Now I will do it on the desktop, and I'm not an expert. I will do only this from PIP, and then auto stacker, and boom, and that's it. I don't go to parameters, different things. That you will do it. You that understand that programs, and if you like, you do it. I'm not too much to those little things. So I just put that. I process the image, and what it gives auto stack, it's what I get at the end. Or Registack. Maybe I will try to put it on Registacks to see what happens. Who knows? You'll see now at the end of the video. Well, I hope you like this real-time video, and I hope it helps some people. One in another thing, one in other thing. One wants to know how to take a picture, another how to catch it, another about the platform, how it works. Well, I think it was a nice moment, and hope it helps. Cheers!